want to see, do go over, have questions about it. Let's see, a lot of 2s and 4s and 3s. So we'll do 2, 3, and 4. Okay. So for number 2, we can use Desmos and put this in. So as I'm looking at these points, they do not make a line. And it doesn't look like they make the curve. I could check it algebraically by dividing. This would be 2, 2, negative 2, so not the same. By multiplying, this would be 8, 18, so again, not the same. So neither was your answer there. And if you use Desmos, as I did, make sure you use Desmos. For number 3, what is the equation of the line if it is shifted down 2 units and reflected? So going back to our linear transformations, if it's been reflected, the slope is going to flip. It's going to have a negative. So the original equation is y equals. So then our new equation, the slope would have a negative. And if it's been shifted down to, the y-intercept is going to move down to. So this is now plus 1. Oh my gosh, it's right. So that should be your new equation. Y equals negative 2/3 x plus 1. In number 4, you are adding these two polynomials together, or really just combining like terms, but there's only one set of like terms. So you have 5x cubed minus 6x squared plus x minus 10 would be your final answer. If you were to check yourself in Desmos, you could put the original in, put the answer in with capital X's, and add the slider, and the decimal should be the same. Just like if you were combining regular like terms. Make sure your name is on your answer sheet and you want to pass that up. Alright, number 1 was B. 2 was D.
Wait, 2 was what?
D as well. 3 was also D. Number 4 had 3 factors, 3x minus 5 and 3x plus 2. Yes.
Yeah, I was going to do 3D. Like, I do get rid of the 15x squared.
So you would, if you were doing this algebraically, factor the numerator using your a equals 1. Actually, yeah, your a equals 1. And then you would end up with 2 factors. One of them would be 3x plus 2. The other one would be 5x minus 6. I'm sorry. Yeah, and then 5x minus 6 would be left. But if you were doing that in Desmos, this would equal this. If you put both of those in, they would overlap. So if you want to see that in Desmos, I can show that after this. Quick overview of what could be done in Desmos. 1 could have been done in Desmos. 2, you could have put in the original and the answer choices with capital X's and found which added the slider and saw which decimals match. This one, if you put the quotient into Desmos, you could see the graph, which line overlaps. For this one, you can't check the numbers by themselves, but you can check the other ones, which one goes through the original quadratic at the x-axis. 5 was D, 6 was C, 7 was also C. 6, 5, all of these you could have put in Desmos. This one you would have had to capitalize the x and y, put these in, see which one matched. There would have been 2, and we're going to talk about how to do this today, but the one that doesn't have other factors, so I think it was these 2. 20 has factors, 1 and 22 and 10, 4 and 5, but 5 is a prime number, so that would be your answer. It's the most simplified. And then same thing here, there were 2 that were your answer. I think it was this one and this 16, yeah. And then when you looked, 16 could be broken down more, but 2 could not. So always go with the simpler one. And then this, if you put this in, only 1 came out to this. Okay. Numbers 8 through 14 will be due next Tuesday. So make sure you try those, work through those. I'm seeing if any questions you have, Max. Oh, I thought you had a question. All right. Are there any of those that we want to see in Desmos or see done by hand? So everyone should have these notes in front of them. Today we are simplifying radicals, so we are now in Unit 11. And after this week, we'll be in Unit 12. So the parts of a radical that we need to know, remember, the nth root of a number a can be written as the radical expression, the nth root of a, where n is your index. This is the radical, and then what's underneath the radical is called the radicand. If there is no actual number outside of here, assume it's 2. We're really just going to be dealing with square roots and cube roots, but the nth root could be anything. Right, and then I'm going to show you 2 different ways on how to do this, and you go with whichever one you would rather. Okay, so if you were solving by square roots, there's really a positive and a negative version of this, but we are just going to focus on the positive versions. One way to solve this is using your perfect squares. Knowing the first 12 is a good way to do these. Sometimes it has to go over 12, but knowing the first 12 is good. So we're going to list those out. If you're not sure in your calculator, do 1 to the second power, 2 to the second power, and keep going. So 1 squared would be what? 1. 2 squared, 4. 3 squared, 4. 16. 5. 6. 7. 8. 64. 9. 10. 100. And then I'm going to go 11, 12. 11. 121. And 12. 142. I think knowing up to 15 is an even better chance that you just know all of them. 20 is like you're solid, you're golden if you know up to 20. But 12 is also good, and you will have your calculator. Okay, so if we have a perfect square, we're just going to simplify it using that. So the square root of 16 is 4. Now that I'm so confident with that, it's okay. 2 times the square root of 121, we would do the square root of 121, which is 11, and multiply it by 2. Yes. And then we don't have this one up here, but in your calculator, do the square root of 289. This one. It's one of those, yes. Figure out which one.
617.
Boom. See, guys, I'm with me. Now multiply 6 and 17.
That's right.
102.
102. Okay. So if you get a perfect square, just simplify it using that. But most often we will not get that, so we have to figure out how we could simplify it. So the directions here is one way. I'm going to show you both, and then you go with that. So if it's a perfect square, use that. If not, the perfect square method is to find the highest perfect square that goes into 32. So think about your perfect squares, think about this list. Which of these, if I divided this, would go into it? 4. Okay, that does, but look for something higher. 16. Because you want to go with the highest number.
I was
16 times 2 would give me 32. And I know the square root of 16 is 4. So this would be 4 times the square root of 2. Now, if you were breaking this down, let's say we used not 16 and 2, let's say we used 4, but not as a perfect square, just, actually, we can do that. So we know 4 times 8 is 32. However, 4 is a perfect square, but 8 is not. So we have to break down 8 into perfect squares or just factors of 4 times 8 is 32. Okay.
I don't understand what you just did at all.
Yeah. The square root of 8, we can't take the square root of 8, but the factors of 8 are 4 and 2. And then I know the square root of 4 is 2. And 2 times 2 is 4. And that's it. So you could break it down like that, or you can use your perfect squares. Whichever one you prefer, you do that. I'm going to do both for one more, and then you guys can choose. So for 180, is that a perfect square?
No.
No. Find the highest perfect square that goes into 180. That's not a perfect square. What'd you say? 121. If I divided those, they wouldn't divide well. So
I think you need 13.
what? 4 and
4 and 5?
4 and 45. I think this would be 180.
Oh, yeah, it is. Oh, and then 5 is 36.
Exactly. Where did you get the 45?
Oh, you divide it by
4, but 36 would be higher.
you divide
Like
So you could go with a lower number, but then you have to break it down more. There's more steps. So if we do 36 and 5, the square root of 36 is 6. And that would just be 6 times 5. Let's say I didn't use 4 and 45. Let's say I know 10 times 18 is 180.
that's a big difference.
I'm just going to list out all the factors of 10 and all the factors of 8. Not all, just one pair. So we have 5 and 2, and we have 9 and 2. Well, I have a pair of 2's right there. Anytime you could make a pair, that's going to come outside of the radical. 5 can be broken down more, but 9, the factors of 9 are what and what?
3 and 30. Or,
That's not what it is. 9 and 1, but we want something like this. So we have a pair of 2's that would come out as just 1, 2, and a pair of 3's that would come out, and then you would multiply. So you guys choose whichever method you prefer.
yeah, I choose the first method.
Okay. When we come back from lunch, we'll do
So what? I think that is what you want.
Alright. do number 10, and then if there are any others, we'll do those. Alright, number 10, do we want to do perfect squares or breaking it down?
Perfect squares.
So find the highest perfect square that 54 can be divided by. 27 and
2.
okay. And sorry, 27 isn't a perfect square. I was thinking perfect cube. What? 25 wouldn't go into 54. 9 and 6. Square root of 9 is 3. And if I were to think about the factors of 6, it's 2 and 3. Neither of those has a pair, so that's just going to stay the square root of 6. For any of these, you can check them in Desmos or the calculator. I'll use this one, but then I'll want to do others if you ask. If I were to put this in, 2 times the square root of 54, and 6 times the square root of 6. Except that's not what I put it.
So,
Then we see that there's, and that's a good way to check this out. Alright, any others we want to see you go over 7 through 9?
Can I do 9 but like the other way?
The separating? Yeah, sure. So give me 2 factors that go into 9, that go into 48, sorry. Okay, let's try to stay away from 1 and 48. 4 and 2. That go into 48. 24. So then, from this, I know neither of these is a perfect square. 2 can be broken down more. What are some factors of 24?
6 and 3. Nope. 6
and
and
4.
4.
Or 12 and 2, either one. If you do the 2s, everything will work with your 2s. You'll just have a bunch of 2s. I know the factors of 6 are 2 and 3, and the factors of 4 are 4. Nope. 2 and 2, sorry. And then every time you see a pair of the same number, so here I have a pair, here I have a pair. So I have 2 pairs of 2s. So this would be 1 pair of 2s, and the other pair of 2. And then that 3 by itself would stay inside.
Oh my goodness, what is that big, large blob on the screen?
This is a pair. This is a pair. Okay. So this is supposed to say 4 times the square root of 3. It just wasn't letting me write. And that would be your final answer. This 3. 2 times 3 gives us 6.
Where's the 4? Was 4 from 2 times 6 and 4?
The 4 was from 6 times 4.
So it's 2 times 2 because there's 2
Yeah,
pairs.
we
So
know
that's
that.
like,
Yes. If there were only 1 pair of 2, you would only put 1, 2. You just write.
but what if there's the 1 pair of 2 and then just the 2 on its own? It would still be just 2.
Say that one more time.
If there would be like 1 pair of 2s and then another 2.
So if it was just like, and you had 1 pair, you would write that 1, and that would stay inside. So anything that doesn't have a pair stays inside the rectangle. Anything that has a pair comes outside.
Oh, is it better that the 3 goes outside and inside?
Yes. It doesn't have a pair, so it has to go inside.
So stack.
Doesn't matter which way you solve it.
No. You should get the same answer both ways. Just with this, you may easily lose a number, so be careful. Okay, go on to the next page. Are there any from 11 through 14 that we want to see you go over before we talk about perfect cubes?
I know my perfect cubes.
Okay. 11 and 13. For 11, perfect cubes, we're breaking this down.
25.
Okay, which one do you want to do? Perfect cubes. Wait, perfect squares, sorry. Perfect squares or breaking this down?
Perfect square.
Okay. 25 and 1.
25. 6. Oh, wait, can't 50 be one?
50 times perfect square.
Oh, yeah, I forgot about that.
It is 6.
25 times 6.
25 times 6 is
Bro, pay attention. The square root of 25 is 5. So our final answer would be negative 25 times the square root of 6, or negative 25 root 6. Either way. Questions on that one? Yes.
You get negative 5.
That was already there.
Bro, max.
I do get 5.
The square root of 25 is 5. Did you ask how you got 6?
I just told them.
Don't you just drop down to 6?
You just keep bringing it down.
Any more questions, Matt?
So,
No? Okay, thank you.
Alright, perfect squares or breaking this down.
Perfect.
Okay. Find the highest perfect square that goes into 28.
I got you.
4.
8 gotcha.
Okay. The square root of 4
2.
and 7 can't be broken down more, so our final answer,
Negative 6 root 7.
negative 6 root 7. Alright, we're going to do the same thing, but now with perfect cubes. So if you don't know them in your calculator, you can use the little caret, hi-hat, whatever you want to call that.
I can list them for you.
Okay, so 1 cube,
1, 8, 27, 64, 125, 216.
go back to 5. Well, what did you say? Sorry.
124.
Okay, thank you.
216, 343, 512, 729, and 1000.
If you don't know these off the top of your head, remember you will have a calculator, but I would say try to remember these. And the biggest thing with this is keep them separate. Don't confuse your perfect squares and perfect cubes because it's very easy to do. Now, you will know that you're using perfect cubes if you see a cube root. If you see a square root, think perfect squares. So for these, it's very similar to what we did before. If you have a negative, you can take the cube root of a negative. You cannot take the square root of a negative. And what you could do is bring that negative out. And the cube root of 27 is
Negative 3.
the final answer would be negative 3, yes.
you see this switch negative to the cube?
I just moved the negative on the outside. Now you could leave it on the inside, you would still get the same thing, but it might just be easier to take it out first. That way you don't have to deal with it.
So for like a question, 18, would you put the negative still on the cube or on the 2?
On the 2. Because she took out the vectors at negative value.
And then the cube root of 1,000, that would be negative 20. So if I put into the calculator 2 times the cube root of negative 1,000, I would still get negative 20.
Oh, let's see.
In our cube roots, when they're not perfect cubes, I'm going to, again, do the same thing. We could do this by perfect cubes or breaking it down. So with this, you have to think of the highest perfect cube that goes into this. 5 and 8. 8 being the perfect cube. The cube root of 8 is 2. And with this, you might want to put parentheses around the cube root so you don't confuse it and say 2 cubed times the square root of 5, but 2 times the cube root of 5. You don't need the parentheses, you can put them if you want. If I were to break this down, let's say I'm using 4 and 10. And I want to break that down all the way. I know 2 times 2 gives me 4, and 5 times 2 gives me 10. If you are breaking it down, you're looking for groups of 3 instead of pairs. So that group of 2 would come out, leaving the 5 underneath. Correct. So again, you do it either way. We'll do both once more, and then you guys can choose. Questions on either of those methods so far?
Is that 5 cube 5?
Right here?
No, above.
Right here?
Yeah.
This is 3. This cube root of 5. Okay, let's try 21. Doing both methods. Perfect cubes. What is the highest perfect cube that goes into 432? So start dividing your perfect cubes. 432 by each one.
7 and 16.
7 and 16. That might not be the highest. Yeah. We could use this one, but it might not be the highest.
It's going to be 216.
So what happens if you don't use the highest is you end up taking the cube root of the perfect cube of whatever it is, but the other one you have to break down. So you would be doing a mixture of the two. Say those numbers again one more time.
216.
With a lot of these, it's going to be 2 and something. So see if you divide it by 2 if that number is a perfect cube. The cube root of 216 is 6. So our final answer, 2 times the cube root of 2. Then if, I'm going to just use the other 2 we just had. 27 and 16 as our breaking down method. Because I know this is a perfect cube, but I have to list out all my factors of 16 because this one is not. So let's just go with 4 and 4 and then break all of those down. I have another group of 2's that we need to come out. So I have the original 2 times 3 times another 2 times the 2 on the inside. And this will give us 12 times the cube root of 2. So you don't have to use the highest, but it's easier if you do. Questions there? Look at the other ones. Which other ones do we want to see or do on this page? So I'm going to start by taking the negative out. And then do we want to use perfect cubes or breaking this down? Okay. So find the highest perfect cube that goes into 250.
Negative 25.
125 and 2. The cube root of 125 is
4.
our final answer would be
10. Wait, do I say times? How do you say the answer?
so 10 times or root.
10 times cubed root of 2.
I'm going to put this one into the calculator just so you see that the decimals would be the same. -2. And then 10 times.
It's a
That will give you the same thing. Alright, go on to the next page. So not only do you have to simplify your radicals with numbers, but you also have to do it with variables. There are a few different ways to go about doing that. You could use this rule. If m is a multiple of 2, you're basically going to divide it by 2. If it's not a multiple of 2, you're going to break it apart. Let's say it was a to the third. Well, I know a squared is a multiple of 2, so I could say it's the same thing as a squared and a to the first. So the different methods, you can think about this like division, where once you get the hang of this, you don't have to show as many steps. You could write it out like this, or you could expand it. So let's say I use this, it is a multiple of 2, so this would be x to the 2 over 2, which would give us just x. If I was thinking this is a square root, 2 goes into 2 how many times? Once. So you have 1. Okay. We have 1x. You were thinking multiplying. It's okay. Or you could expand it. I know x times x is x squared. And this is a pair that would come out. So whichever way makes the most sense to you, use that.
Wait.
Did you have a question, Brian?
I just have confusion. Okay, on what happened to
We divided.
okay.
No. Okay. This is basically the same thing in a different format. 2 goes into 2 blocks. Or we could expand it. And this is one pair that will come out. And there's no one there. Okay, go ahead. That's for the index. So we're going to do number 3 and then go back to number 2.
Wait, how do you x times x?
That's what x squared is.
Okay.
So we're going to do all 3 of these. 5 is not a multiple of 2. So I could use this rule. And I know 4 is a multiple of 2. So I could change it to n to the 4th times n. Because that would be the same thing as n to the 5th. And then I could use this rule and say n to the 4 over 2. Which would be n squared times the square root of n.
Wait, where did the 2 come from?
Which
The one where it's like n over 4 and 2.
that's in the.
Oh, it's a part of the equation.
So you could do it that way, or I could think about this as 2 goes into 5 how many times? What? Twice. With how much left over?
1.
Or I could expand it.
Wait. So like if we did it that kind of way, how do you show our work?
You wouldn't. That is your answer. That's why I said you could do it either of these ways. Once you get the hang of this, if you want to do this, 2 goes into 5 twice with 1 left over. That's it.
What's the 4 over 2?
4.
This exponent over the index from this formula.
How do you 4? It was in the 5th.
It was. but 2 doesn't go into 5 evenly. It goes into 4 evenly, so we made it 4 and 1. If you expanded it, how many groups, how many pairs of 2 of n would we have?
2.
Which would be your n times n with 1 left over. So however that makes sense to you, do that. Now for number 2, we now have numbers and variables mixed together. Is 9 a perfect square?
Yeah.
Yes. So what I'm going to do is separate all of these. I know the square root of 9 is just 3. And then let's say I'm using this method. 2 goes into 10 how many times?
5.
5. So that would just be k to the 5th. There'd be nothing left on the inside. Questions on that one?
30K.
Yes, that would be your final answer. Oh, okay. Let's try number 4. I'm going to separate each thing first. Excuse me. Is 40 a perfect square? No. So using either your perfect square method or your breaking it down, give me 2 factors.
20 and 2.
Okay. 20 and 2, we're breaking it down. 4 and someone said 4 and 10 perfect squares. So whichever method you prefer, do that. If you want to see both, we'll go back and do the others.
So
2 does not go into 19 perfectly, but how many times would 2 go into 19? 9. With 1 left over. The square root of 4 we know is 2. A to the 9th would be right next to that. On the inside, we have 10k.
Maybe if you were paying attention, yeah,
You are talking. Do we have questions there? Okay.
So when you're breaking it out by perfect squares, it has to be not both of them perfect squares, just one.
Just one.
Doesn't matter which one.
It doesn't matter. I usually put the perfect square first, so it's just easier, but it doesn't matter. Other questions on that one? Did anyone want to see that one broken down instead of using perfect squares? Okay. Give me 2 factors of 40.
Okay, Max, since you're the one that wants to give 2 factors of 40.
40 and 2. Okay.
Contribute.
And then factors of 20.
10 and 2.
And factors of 10. So of this, I only have 1 pair. These are just going to stay underneath. I have the square root of 10. And then with our variables, you could do that the same way. You could break it down. That's up to you. If you like this method and want to just do that same thing, then you have a to the 9th times the square root of a, and then you just combine them. So you have a lot of different choices when simplifying both pieces. Any questions there? Let's try number 5. The square root of 25 is 5. 2 goes into 6 how many times? 3. And 2 goes into 13 how many times? 6 with 1 left over. So final answer, 5x to the 3rd, y to the 6th times the square root of y. So if you have questions, please ask. Jackson.
So we just like So we just divide by 2.
The exponents for the variables, yes.
Okay. And where's that y going? The last wall.
2 times 6 is 12, with 1 left over.
So
5x cubed y to the 6 times the square root of y. Look at, I'll let you guys choose 9. We're going to do one of these. 9 or 10. Okay.
fair.
I'm going to separate each thing first. And then either using your perfect squares, find the highest perfect square that goes into 320, or find 2 factors that go into 320.
320 times 1.
Not using 1 though.
160 and 2.
Okay, we could break it down. We need 2 factors of 160. 40 or what? 40. For this. 40 and 40. And then factors of each one. 8, 5, 10, 20. We could do either or, sure. And then factors of each of that.
Each of what?
8 and 5 and 4. And then break. So here we have a pair of 4s. You could break them down more, or you could leave them. But we have a pair of 5s, a pair of 4s, and a pair of 2s with 1 2 left over. So that would be the original 8 times 2 times 4 times 5 with the square root of 2.
Nice.
Or you could have found the perfect square and we could have avoided that. Can we do more with this? Can we simplify this? The square root of x? No. It's just going to stay the square root of x. Because 2 doesn't go into 1. But 2 goes into 4 how many times? 2. Twice. Multiply 8, 2, 4, and 5.
8 times 2 times 4 times 320. You knew it was going to be.
I didn't actually. How did you come with this with your other classes? Not this problem. And only first period. Respect y squared 2x. Questions on anything there?
Oh, that's the final answer.
That is the final answer. If you are checking this on the calculator on Desmos, in Desmos we know that we can put these in as capital letters, add in the slider, and then put in the answer choice and see if the decimals match. On the calculator, you can't put in the variables. You could put in the number to see if that decimal matches, but there's not a way to check yourself in the calculator for the variables. You could check in that. Alright, we'll do one more of these and then move on to the cube roots with variables. 11 or 12?
12.
Okay. So if I break everything down, rewrite everything. Square root of 1.4 is 12. 2 goes into 16. How many times? 8 times, so x to the 8. 2 goes into 10. How many times? 5. So y to the 5th. And 2 goes into 7. How many times? 3. Correct. So that would be z to the 3rd times the square root of z. Multiply negative 5 and 12. And then negative 60, x to the 8th, y to the 5th, z to the 3rd times the square root of z would be our final answer. Questions there? Go on to the next one. So now we're going to do basically the same thing but with cube roots and variables. Here, same thing if you like this rule, it would be a to the m over 3. If it's not a multiple of 3, you'd have to break it apart so it is. Or you can use the 3 goes into 3 how many times and see what's left. Or you could expand it. So we're going to do one of each and then move on from there. So let's skip 14 for now, do 15 so you can see all the different rules. So if I'm using this, I know 3 does not go into 7 well. But I know 6 does. So in this case, there would just be 1 left over. But sometimes it's 2. It depends on the problem. And I know this would be the same thing as p to the 6 over 3, which would be p squared. Or you could have looked at the original. 3 goes into 7 how many times? Twice with 1 left over.
3.
Or if you were to expand it, 5, 6, 7. I'm looking for groups of 3. So each group would come out, side of the radical, and then whatever is left by itself would stay inside. So this it would give you the same thing. That'd be great. So you choose whichever method you like the best and use that. Let's do 16. So just like our square roots break everything down, separate everything. Is 40 a perfect cube? No. So find the highest perfect cube that goes into 40. Negative 3 times the cube root of 8 times the cube root of 5. 3 goes into 16 how many times?
5 times the leftover.
Yes. So there would be w to the 5th, because that would be 15 with 1 left over, the cube root of w. The cube root of 8 is what? 2. So we have negative 3 times 2. I'm going to start to rearrange, times w to the 5th, times the cube root of 5w. So that our final answer would be
Cube root 5w.
yes, I just wrote that off to the side. And if you want to use parentheses, you can do that. Look at the other problems on this page. Which other ones do we want to see you go over and have questions about?
22.
Which one?
22.
rate each one. Find the highest perfect cube that goes into 192. Three goes into 8 how many times? Twice. With how much left over? 2. So that would be r squared times r squared times the cube root of r squared. 3 goes, does 3 go into 2? No. So that one's going to stay the same. And then 3 goes into 18 how many times? 6. So t to the 6. The cube root of 8 we just found was 2. So on the outside we have 2 r squared t to the 6 times the cube root of 24 r squared s squared. Just to make sure, if I were to break down 24, I have 6 and 4. I don't think 8 and 24 was the highest. Because there's another set of 2s that can come out. So this would actually be 4, and this would be 3. But if you get down to the end and you still have a number inside that's maybe it looks big, make sure it can't be factored down anymore, or that you don't have any pairs or groups that can come out, depending on what the problem is. Do we have any other questions?
What's the exponent of t?
6. Is that what you're talking about?
Yeah, I thought you had to divide by 2, so
So in the cube root, you divide by 3. Alright. So then for the remainder of the class, you guys can work through practice on this. You guys do have a delta math on this. It's due Friday. Work on past delta math. Work on JLabs. Work on SOL Testnav things on the iPad, just in the packet, whichever. Use this time wisely. 8 through 14.
I was trying to make it.
We prove one though.